Hi, I'm John McPhail from Matex Control Chemical in Calgary, Alberta, Canada. I'm going to speak to you on our environmentally safe rock drill oil. It's a vegetable product manufactured specifically for lubricating downhole hammers in the mining, construction, and blast hole industry, water well. There's all kinds of applications where downhole hammers are used. Our job is to lubricate them as best as possible and be environmentally safe. In this video that we have right here, this will actually show how the RDO 302ES adheres itself to the metals. As you can see right here, if my little red pointer shows up, how the product actually climbs up the drill steel, and this is over the weekend. It's a 2-day climb, and it's about 2 3/4 of an inch. So this is our rock drill oil sitting in the bottom of this beaker. We put our piece of steel in here, and it actually starts to climb up. So it's a fantastic penetrating lubricant as well. Eventually, if you leave that in there, that will start to remove the rust that's on this metal, and it'll keep it good and shiny out in the rain, in salt water, whatever. It'll keep it well lubricated. This video here, we're showing this is a piston out of a downhole hammer, and we're just applying a little bit of our RDO 302ES rock drill oil onto the piston just to give a good visual as to how this product sticks to the metal. It doesn't matter how long you try to wash it off or what your pressures are with these pressure washers. You can put soap, you can put foam, you can put whatever you want in there and wash it for as long as you want, and you will not wash this rock drill oil off of this piston. The film that you see that the product is left on there, you can see the water that's beading on there. The film that is left on there has a film strength in excess of 100,000 psi. And what that means is that you can see where the water is beading there. So what that means is that where that lubricant is and has left its film on that piston, that at any one point, if you put down a pressure of 100,000 psi on this area where the lubricant was, that it's not going to break the film of the lubricant that is on that hammer. Here we're showing some of the world's leading manufacturers of downhole hammers, such as this one here is an Ingersoll Rand 30-inch hammer, which is the largest single-cylinder piston that's manufactured in the world thus far today. This is a job site in Finland where we're using the RDO 302ES to lubricate these hammers. Also on the cluster drills, as you can see in this picture over to my far right, the cluster drills will have 5 to 8 hammers and depend on the size of the hammers that's in there, depend on the size of the holes that they're looking to drill. This one I believe is about a 5-foot diameter hole in Slovenia, and that comes out of their rental division. They prefer, if they're going to rent their hammers, they know that they can't protect the outside of the hammers, but they can protect the inside of the hammers if they use a good rock drill oil, which is our RDO 302ES for lubricating the inside. But also lots of these hammers, this is mainly for a construction job, and lots of these hammers are used around salt water and for docks and large buildings, etc. So you have your rusts there, but also environmental concerns. Huge environmental concerns when you're working around shipyards and et cetera, because you're drilling right out into the ocean. And the same with lots of these larger hammers, because they're running under-reaming systems such as this one here, which just takes the casing down, which they're using in piers. So you get lots of leakage and seepage out into the ocean. And if we can take care of that before with an environmentally safe product versus dumping a petroleum-based product in there, we're ahead of the game already. In this animation here, we're showing the lubricant coming down the drill pipe. We're showing it in green because it's environmentally safe, but it'll coat all the drill pipe. It'll coat everything until it gets down to the hammer. The piston that's working on the inside of this case here, you can see the red, that's where it's getting hot. That's where you get your friction. So right here is where we try to keep our tolerances, keep the heat out, keep the friction out, and keep our tolerances there. Another thing that people forget about is the splines and the shanks, etc. So if we can keep this area lubricated here, your driver sub is going to last a lot longer, as well as the splines on either your downhole bit or your under-reaming system or what have you. Obviously, the larger the bit that's on these hammers, or the larger the underreaming system, the more pressure that's on these shanks, and it tends to wear out the inside of the driver sub a lot quicker than just a normal size bit for these hammers. So again, right here is our area that we're trying to lubricate, is on the inside of this hammer. If we can keep those tolerances to within manufacturer specifications, this hammer will keep up its production, it'll keep the performance going, it'll keep its penetration rates going through the life of the hammer. We have had customers report 40 to 60% increase in hammer life. That's overall hammer life from using previous lubrication of a different sort of petroleum product. This particular slide here is an interesting slide, and it's very dear to my heart because I had about 18 years ago, I had sold 14 SD4 HD hammers, and back then when they were manufacturing these hammers, you could see that the HD part is meant heavy duty, so it's an SD4 HD, 4-inch hammer, HD being the heavy duty wear sleeve. At that time, they only manufactured the heavy duty part in the wear sleeve and not in the top sub or the driver sub, as you can see in this hammer. So this job went on at a dam site, an earth dam in Western Canada, and there was 14 hammers provided on that job. 7 of them had got lost and cemented in the hole. The other 7 that were finished were still there on a pallet when the job was finished. All 7 of them I had got these hammers back. They all looked like this. As you can see, there is the hardened case on the wear sleeve itself where the threads are, and this is the HD part, which is right here. It's actually worn opposite to what we're showing here, and it might be able to show up better on this one here, but it's warped paper thin, and here is the internal parts on all 7 of those hammers. They're still shiny, brand new, because even back then, 19 years ago, I had provided RDO 302ES rock drill oil to this job site, and I'm glad that I did, because all of these, when we got these 7 of these hammers back, we took them into our shop and mic'd every piston and measured the internal case, the ID of the case, and everything was still maintained manufacturer's tolerances and specifications, and absolutely no rust whatsoever. So as these hammers were drilling, you can see the wear that was on the outside as they were drilling to get down to where the case itself was actually paper thin, and everything else on these hammers were like absolutely like brand new. It was amazing. There are a few credentials, a few testimonials that Control Chemical has received over the years from different end users, manufacturers, etc., of downhole hammers. This is one of the manufacturers that has written a testimonial for Bob, Eastern Drillers Manufacturing Company over in eastern U.S. They are a hammer manufacturer of smaller hammers. This is also a testimonial from DTA out of Australia for RC hammers, written by Mr. Brian Sandfeed. And Brian in here speaks of using an RC hammer in Nevada, and then going ahead and the lubricator wasn't working. He was actually just pouring the lubricant down the drill pipe. Then at every joint, so you're not getting a good lubrication opportunity anyway when you're pouring it down the pipe versus using a continual injection. Then they started to use some drill foam, etc. And when they pulled out after the hole was finished, as Brian continues to write in here, that he was surprised to see how much lubricant was still on the hammer, because foam in itself is a detergent and it will wash off petroleum products, etc., where it won't wash off the RDO 302ES manufactured by Control Chemical. Another bit of a testimonial here, and it's a case study from a job in a copper mine in Chile, down in South America. There's also following documentation to support this in this presentation, but we had one drill running on a bench, two drills running on a bench, one side by side. When the hammer on one drill, the drill that was not using the RDO 302S, when it was finished, it had shown that the RDO 302S, we saved 2,300 or 23.25 hours of drilling time. Because we were able to keep the internal parts in the hammers within manufacturer's specifications, it kept the penetration rate up as if the hammer was brand new. It never dropped off in penetration, where the other hammer that wasn't using the RDO 302ES had fallen short. So in essence, I believe we were 3.82 meters faster in penetration across the board, which results in the 23.25 hours. So if you take an estimated rig cost of $240 per hour and multiplied by your hours of savings, we actually show $5,580 just on penetration rates alone. And in a production blast hole drill, it's production, they call it production for a reason. That is everything. That's very important. So here we are on the same, from the same testimonial that was initially written in Spanish, translated, and we also showed an increase of 40% in the life of that hammer, plus, added to the penetration rate increase. So here's our hammer with the RDO 302ES versus the other lubricant that had been used, and you can see the 243 hours versus the 220 hours. So that's where we get our numbers from this documentation that had been provided, plus an increase in lifespan of another 40%. So you can do your calculations on that to see what your actual overall savings were. So if we have both of these hammers, the one in the top one here, we're using Matex RDO 302ES rock drill oil on, and the other one using just an ordinary petroleum-based hammer lubricant, you can see that we're starting off on our penetration rates, which it should be, to be exactly the same. As the internal part starts to wear a little bit, our penetration rates will continue to drop off, and they'll drop off more and more and more all the time. So where some of this comes from, and especially in a copper mine, you will see when they're always injecting water, just enough water to keep the dust down. And what happens is this water is not necessarily the cleanest water, and usually in a copper mine you'll see it can be quite acidic, which will contribute to internal parts of anything rusting quite quickly. So if the rust gets in there, it starts to wear the internal parts, the outside of the piston, the inside of the case, which opens up our tolerances, lets your air blow by, and it's not using the air for the energy on the piston to give you the penetration rates. So by keeping this hammer lubricated up top with a good lubricant, such as the RDO 302S, we were able to maintain the penetration rate all the way through the continual life of this hammer at 6,395 feet. So remember, the internal parts are fantastic. They're still within manufacturer specifications right here. They're still like brand new. Where this hammer here bombs out at 6,355 meters, that hammer is completely gone. So you take your costs of your hammer divided by your meters, and there's your cost per meter per hammer. So at this point, we add an econo kit to this hammer, and we continue drilling at the exact same penetration rate. So this thing continues to start saving more money and more money all the time. I'm not sure where this hammer ended up, but if it doubled the life of this one, then basically it'd be to get this hammer over there to do that would be twice the cost of this hammer, where it was only 1.5 the cost of this hammer, plus the penetration rate, which is huge. The penetration rate, as a matter of fact, in a production blast hole industry turns out to be a lot more critical than the increase of the life of the hammer itself. So this is a very important chart. From there, we go into our Excel spreadsheet that we have put together. And this is just for an example only. For these numbers, you put your own numbers in because we have the spreadsheet, but you can change any of the number in blue to suit your job site and your costs, etc. So this is already set up to work out our calculations to find out what our present costs are versus what our costs could be. Then we have an increase with an assumed increase. We can put whatever percentage in there. This one's it's 0 because it doesn't matter. It's just for demonstration purposes only. Your average ROP, an increase in ROP, et cetera. So your increase in your meters per hour, which again all comes down to be calculated. Your drill costs per hour, it's all in there. So you get your total savings with your ROP, plus your econo kit, et cetera. Then the interesting part is these numbers can get very high very, very quickly as your drills on site and your annual savings per year. So if you have 10 drills, all of a sudden we're up to $620,000 in savings per year when all we have done was changed your rock drill oil. And we have proven this numerous times, but most people don't take the time to check out to see what your rock drill oil is actually costing you. We're not asking you what it's costing you, is how much do you think it will save you? How much can this product save you? So we continue on with this. We can go as far as we want with it, but we can add your econo kits in there, and how many econo kits can you put in there, which obviously reduces your cost per meter, et cetera. And we're just getting down to the bottom line as to what this rock drill oil can save you in your operation. Some of the mines down in Nevada, in the U.S., they have experienced huge increases in their hammer life, and they purchased the product not only in pails or 55-gallon drums, but they purchase it by the tanker load. This tanker will deliver from the factory in Calgary to the mine site. And from here, it's pumped into a holding tank that they have on the mine, and then from there into their lube truck, and the lube truck continues to go around and top up the lubricators every day. This is a fun little video that I like. This is our rock drill oil, 302 ES, right there that the fish is eating. They actually enjoyed the product. So if it's ever spilled out into the ocean or whatever, if you're drilling by the ocean, as I mentioned before, in salt water or what have you, and some product gets out and leaks into the ocean, the fish will actually come along and clean it up. So there's not even usually a cleanup crew required. So we have the one type of rock drill oil, but one is soluble and the one's non-soluble. And this cloudiness here is the RDO 302 ES soluble that's mixed with the water, and the top one is obviously the one that's non-soluble right here that the fish like to eat. So that's our quick demonstration, a little bit of information on Control Chemicals RDO 302 ES rock drill oil. Thank you.